Assalamu alaikum, dear students. Welcome to Power System Protection course. My name is Yousuf Al-Shaili, and today I'm going to discuss with you Lab 1 in Power System Protection Current Transformer Test. We're going to discover the CT, current transformer, very important component in power system. What is it, where to use it, and what are the different tests we need to apply to this CT before we install it in power system. So, prepare a cup of tea, relax, and try to enjoy the lab. So in order to perform this experiment, we are going to use power system simulator, and for this one we need free CT to be tested, CT which is not connected to any of those relays, protection relays. We have here relay K, which is been removed from the simulator and replaced by those microprocessor relays. So we end up of this free CT here, CT for relay K. They are free. We just need to remove those jumpers. So we have B1 and B2. Okay. Those are the three CTs. We just need to, we're going to use this blue phase, so we need to remove those jumpers. So we have primary B1 and B2 and secondary S1 and S2, and we are going to test this CT. We'll see first the characteristic, what is the ratio test for this CT and whatever. And we're going to test it for three tests. As we mentioned before, the polarity test, the ratio test, and the magnetization curve test. Okay, let's do it. Let's have a look first at the CT from the back side of the generator of the simulator. These are the CT, those how they look like, and those CT are numbered like CT9, CT8 according to their connection to the relays. Those are the primary, and you can see those wires are also numbered, so it is easy to follow the connection. And those small wires there are the secondary. You can see they are written there S1, S2 secondary, and B1 there, B1, B2 for the primary. So the secondary are connected directly to the relays. Okay, and if we see this one, the data for this CT, if we have a look at this one, you can see the data, the ratio 10:1 amps, BS3938, 50 or 60 hertz, the resistance at 75 degrees 1.825, 5 volt amp, the percentage of error is 5B10. So you can use these data. These are the data for the CT that we are going to use today. You can use this data for your calculation. Let's start part one of this experiment, the polarity test or the polarity check. What we need is only a battery, 9-volt battery, and a meter, analog ammeter. It's better to have analog ammeter. We are going to connect the battery to the primary, and we'll use the ammeter to see the deflection in the secondary. So if we apply a positive to B1 and negative of the battery to B2, we can see the deflection if it is in positive or in negative side. Okay. Of course, the battery is only one touch, is not permanent touching. It's only instantaneous touch for the battery. Let's see how to do this. So these are the equipments we're going to use. We have the analog ammeter. We're going to use it in DC. We're going to connect this one to the secondary, S1 to positive and S2 to negative. So, and then we're going to connect the primary to the battery, 9-volt battery. So we'll see when we connect the positive B1 to positive, what will happen to the ammeter, where will be the deflection, in positive side or negative side, and if we connect it to negative, what will happen. So we'll connect both sides and see the results. Okay. Start the test. Let's connect the battery. You can see that the secondary is connected to the multimeter, S1 to positive, S2 to negative. So now if we connect B1 to negative, you can see that it is going to the left direction, to the negative direction. But if we connect it to positive and B2 to negative, then it's going to the right direction. Okay? So this is how to test CT. Now CT is working fine with this test. And now for part 2, the CT ratio check or CT ratio test. As we saw in the data from the winding, the CT, sorry, the current transformer we used, the 10 ratio is 10 to 1. But we need to check this one. So what we are going to do, as in this figure here, we are going to inject a current to the primary, vary this current, and measure the current in the secondary and see the ratio. For that reason, we need special equipment we have in the lab called MK4 100. So we can use this one as a current source to inject a current to the primary. And as you can see here, we have two methods for turn ratio or the ratio test for the CTs. The first one is the primary current injection ratio test or the secondary voltage injection method. So as you saw, what we are using here in the lab is the primary current injection. We're going to inject a current to the primary and check the corresponding current in the secondary. And also you need to fill this table with the 3 values for primary and the corresponding secondary. So don't forget to fill the table. So let's see how to do this. So you can see now, if the voltage is 1, it is 0.1 on the secondary. When it is 2, it is 0.2, so it is 10 to 1. 3 is 0.3. So from this one, you can take 3 readings and fill your table. Fill the table with 3 readings. See, when we reach 5, is 0.51. So it's exactly 10 to 1 ratio. This is the primary voltage, and this is the secondary voltage. Sorry, primary current and secondary current. Up to 9.7. We cannot reach 10 because this multimeter can measure only up to 10 amp. Now let's start part 3 of the experiment, the magnetization curve. This is our connection. We're going to use only the secondary. The primary will leave it open. For secondary, you are going to connect an AC source to the secondary and measure the current and voltage so that we can draw the relation between the secondary voltage and secondary currents and find the magnetization curve. And on that magnetization curve, we need also to find what we call the knee point. You can calculate this one using the equation so that you can understand where exactly to search for the knee point. Once we reach the knee point, then any 10% change, a 10% change of the voltage will result on 50% change on the current. Okay, and then you are going to enter what we call the saturation region. So initially the current is not changing much with the voltage, slightly changed. You can see it's almost linear. And then once we reach the knee point, 10% of change of the voltage will result on 50% change of the current. You need to fill this table with the secondary voltage. We'll start with 10, 20, 30, 40, 50, up to 60 volt. And then you need to take the secondary current. Once we reach 60, we are going to search for the knee point. And then we'll take also different reading in saturation so that we can see the high change in current for that point. Let's start. So in order to perform this experiment, we need 2 multimeters, one analog. We are going to use this one as an analog multimeter to measure the current. And I'm going to use the scale of 0.1, which means that this 10 we need to divide it by 100 so that it is 0.1 amp. And this will be 0.01, 0.02, or we can say this is 10 milli, 20 milli, 30 milli, up to 100 milliamp. This is for the current meter, the analog meter for the current. And the digital meter here, we are going to use it for voltage to measure the AC voltage of the secondary. Only one point you need to take care of is that once we start increasing the voltage, we have to go in one direction, forward direction only, which means that if we want to go to 10 volt and by mistake we go to 12 or 13, we cannot go back, we cannot decrease it, otherwise we will have high stresses error. So we have to go only in one direction till we finish. So we just take the reading which occurs there. Okay, let's start. So let's start by varying the voltage. Let's go initially to 10 volt and see what should be the current. Don't forget to record this your table. So 10.3, it is 4 milliamp. 4 milliamp, write it down. 10.3, 4 milliamp. Let's go to 20 now. 20 volt. So 20 volt is 6.5 milliamp. 6.5. 20.6 volt. 6.5 milliamp. Let's go to 30. 30 volt is 9 milliamp. 30 volt, 9 milliamp. Write it down in your table. And let's go to 40 now. 40 volt, 11 milliamp. Write it down. 11 milliamp for 40 volt. Let's go to 50. 50 volt, we have 14 milliamp. 14 milliamp for 50 volt. Now let's go to 60. We said 60.4, 19 milliamp. 19 milliamp for 60.4. Now let's go to 60 point, let's say 63. Let's go to 63. Now you can, of course, you can calculate the knee point and you can figure out where to search for the knee point. So for this lab, I'm going to search at 63.9 for, sorry, 63 volt for the knee point. Okay. Now check the volt, the current. The current for 63, this is almost 63. The current is almost 22 milliamp. 22 milliamp. Okay. Is less than 22, but let's say it is 22 milliamp. Now we're going to take 10% of this 63. So 10% is 6.3 plus 63. It is 69.3. So 69.3 is 10%. I mean, adding 10%, that is 69.3. Will this current change by 50% or not? If it changed by 50%, then that is 63 is the knee point. So we are going to 69.3, and the current, if it reach 33, because it is now 22, and 50% of 22 is 11. So 11 plus 22 is 33. So if it reached 33, it means that 63 is the knee point. Okay, you understand this? Let's increase the voltage to 69.3 and see what is the current. But let's increase the voltage to 69.3 and see if the current will reach 33. If it does, then this is 63.3 is the knee point. So the 63 will be the knee point. So let's see. 69.2. You see, when 69.2, it is almost 69.3, and you see the current is 35, is more than 33. So we increase the voltage. It was 63, we increase it by 10%, and the current increased by 50%, which means that 63 is the knee point for this one. Now we'll continue. Take this one, write it down, 69.2, and the current is 35. You can write it 69.3, it's almost the same. Current is 35. Write it down and take a note that this 63 is the knee point. So now we know the knee point. Let's now increase the voltage more and see now how the current is increasing rapidly now. Try to take more points for your table. I'll just leave this one for you. I'm going to increase it now. See how the current is increasing fast. Let's change the scale of the meter so that we can see more. Now the scale is at 1, so this is 0.1 amp or 100 milliamp, 200 up to 1000 or 1 amp. You see now by small change in the voltage we have high change in the current. Okay. Now once we enter the saturation region, I want you to listen to the sound of the source. Can you hear the sound that the source is making? That is when we enter the saturation region. Okay, so the source is loaded now. Okay, this is about the experiment. We made we performed three tests: the polarity test, the ratio test, and the magnetization curve test. So I hope you enjoyed the experiment, and just stay safe, and see you in the next lab inshallah. Thank you very much.